This video will demonstrate how to prepare a TLC plate, apply a sample for analysis, develop the plate, and analyze the results. For the theory behind thin layer chromatography, or TLC, you should consult the introduction of the experiment or the Padilla's textbook. Our TLC plates are plastic cards with a layer of silica gel on one side. The gel acts as the stationary phase for the chromatography. To prepare the plate, I want to lightly draw 2 lines in pencil across it. The first line is placed 1 centimeter from the short edge of the plate. This line is where I will apply my sample. The second line is drawn about 75% up the plate, giving a guide for how high the solvent will travel up the plate. When I apply these lines, it's important not to scratch the silica gel off the plate. Once the plate is prepared, I'm ready to apply my sample. I'm using the crude dibenzoyl ethylene here to show how TLC can separate the components of the mixture. The sample is dissolved in 0.5 milliliters of acetone, and I will use a very small capillary tube to apply it to the plate. I will dip the capillary tube into the sample and then apply the tip of the tube to the lower line that I'd drawn. You can see that the liquid deposits from the capillary tube onto the TLC plate. If I'm applying more than one sample, I'll try to space these evenly across the sample line, and I'll need to note in my lab notebook which spot is which. I can check the plate with a UV lamp after the solvent has dried. The silica gel has a fluorescent dye that the sample obscures, appearing as a purple spot. I only want to see this spot on the plate right now, and the spot should not be very large. I can now prepare the TLC development chamber, which is a 400 milliliter beaker. I will fold a piece of filter paper in half and place it flat end down in the beaker. This paper will help saturate the atmosphere of the chamber with mobile phase. I will then add 10 milliliters of my mobile phase into the beaker. Some of which will start climbing the filter paper. Next, I will place my TLC plate into the chamber with the sample down. You can see the sample line is above the solvent level in the beaker, but the solvent climbs the plate by capillary action. I will then cover the beaker with a piece of aluminum foil and let the mobile phase climb the plate to the second line. I will pause here because this typically takes 10 to 20 minutes. Okay, We're back, and the mobile phase has reached the second line on my plate. I will remove the plate from the TLC chamber and allow the mobile phase to evaporate. This should take a minute or two. Once the mobile phase has evaporated, I will shine the UV lamp on the developed plate. The components of my sample will have separated, and I need to circle each of these with pencils so I can still see them once the UV lamp is off. To analyze the plate, I will need to measure the distance each spot traveled from the lower line, measuring from the top of the spot to the line. I will then divide each of these distances by the distance traveled by the mobile phase, the distance between the two lines. This generates dimensionless RF values for each component of my sample.